Let's look at question number 10 and 11 of your practical list. Question number 10 says, write an assembly language program that reads in integers and adds them together until a negative non-zero number is read in. Okay, so basically we have to keep on reading the integer and keep on obtaining their sum, okay, till the user enters a negative non-zero number, okay. Then it outputs the sum not including the last number. Then whatever the sum has already been obtained, okay, excluding the last negative number which was entered, okay, that is to be outputted to the user. Okay, so let's see how to do this. I'm going to go over the outline of the program with you first. So please see, we are going to be using two labels here. Okay, one is the start, one is the done. Okay, what is the use of these labels? These labels allow us to perform looping in an assembly language program. As we have already discussed, an assembly language program is a low-level program and it does not have constructs like for or while loops explicitly to help you loop. Okay, so we must do it indirectly. Now, how this looping is done, you will see with the help of these labels. So, what do? We just read a number, check if it is negative, then we simply stop adding the numbers. Okay, so what this instruction does is it says that jump negative. That means if the number which has been entered is negative, then jump to done. So done is a label. Okay, here what we do, we load whatever the sum, whatever the value of this variable sum has been obtained so far, we load it back into the variable sum and we load it into the accumulator and we write the value of AC, show it as output and we stop. Now, please see if the number that we entered was not negative, then what we have to do? We add it to the sum as usual as in our original program. Okay, we used to do, we add it to sum and then store this added sum which is stored after this instruction in AC to this variable sum in the memory. Okay, now, after this number has been added, we go back to what do we want to do? We want to read the next number. That means we want to go back here, right? So what we do is we say jump to start. That means go back to start. So you see how this is an infinite loop, which is broken by this statement here, okay, which says that if a negative number has been entered, if the number that you have just entered is negative, then you jump to done. Is this clear? So this is how you see we are implementing a loop. Okay. So let's see. You've already seen all these instructions: read and add and store, right? Let me show you the implementation of this, how to make these machine instructions jump and jump in. Okay, but before this, let's just execute this program and see how it works. So I'll say assemble, load and run. It is asking for integer. Let me enter 3. And then since it was, please see, since it was not negative, then it has gone to add sum, and then you can see the value of sum right now. It is 3, right? Now let me give it 4. Okay, again you can see that the number is not negative, so it has been added to sum and it has again gone back to start. That means to this read instruction, and it is asking me for another number. Let me put 5 this time. Okay, so the total sum is 12 so far. Okay, and again it will go back to read. This time let me enter -1. Okay, so you see that as soon as I have entered -1, it has given me the output 12. Okay, so 3 plus 4, 7 plus 5, 12. Okay, and then it has stopped. Okay, now let us see how to implement these machine instructions, jump and jump in. So jump is very simple. You see what we need to do here is we're simply saying jump start. That means whatever is this address, okay, whatever this is the opcode, okay, and this is the address part of the instruction. So whatever is the address part, you go to that place. That means we need to put this address into the PC as we did it in bun. So the same implementation of bun, please see. So here you can see this is the jump machine instruction, and you can see I'm simply putting this part of the instruction, that is 4 to 15 bits, into the PC, and that's all. Okay. Now let us look at the implementation of jump in. Okay. So now please see, what do we want to do in jump in? Let's understand that first. So the objective of this instruction is what it is saying is that if the number that you have just now read, right? If the number that you have just now read is negative, then jump to done. Okay. That means if the number which has been read is negative, then address, this address should be transferred to PC. Okay. However, if the number is not negative, then should we transfer this address to PC? No. Then the PC will already contain the address of the next instruction, which is add sum. So what do we have to do in that case? Please don't do anything. Okay, please don't do anything. So I'm repeating, what we are saying is that if, what this actually means to say is that if the number that has been entered is positive, then don't do anything. If the number that has been entered is negative, then transfer this address to PC. Okay, now let's see how this is done. So you can see that jump in, okay. What is this? This is a kind of a test micro. You can see it here. Okay. Now in this test micro, what we are saying is, see, in this implementation, what we are saying is that you transfer this line. What it says is it says ki you transfer this address to PC. Okay. And what this line says is that if AC is positive, then don't do this. Okay. So how do I specify this? I'm just given this the name. I'm saying that please check the accumulator register. Okay. Please check the accumulator register. Okay. Starting from the bit 0, check all its 16 bits. Now, if it is positive, okay, if it is positive, I'm sorry, this is the micro for this. If it is positive, that means if it is greater than equal to 0, then omit the next instruction. What is the next instruction? This instruction, which is there in the implementation. This is to be omitted. That means that as we had discussed, don't put done in PC. Don't put done in PC. In that case, what will happen? Automatically, PC already has the address of add sum, okay, which is the next instruction to be executed, and it will be automatically executed. Okay, so what we are doing here, let me explain it once again. So in jump n, what we are saying is that if the number is negative, okay, if the number is negative, please see, if the number is negative, then there will be no skipping, then this will be executed. If the number, however, is not negative, that means positive, we are checking here, please see, if AC is greater than equal to 0, okay, then omit the next sentence in this implementation. That means don't do this, okay. Now let us look at question number 11. So the question number 11 is exactly the same. You can see that the only difference is that it says write an assembly language program that reads in integers and adds them together until 0 is written. Then it outputs their sum. Okay. So this time, let me open the assembly language program for question number 11. You can see it is exactly the same as question number 10. The only difference is that instead of jump n, I have used the instruction jump 0. Okay, that means I'm saying that read a number. If it is 0, then you jump to done, where you load the sum obtained so far, okay, into the AC and write it, and then you stop. Okay, and then you stop. Clear? If the number, however, is 0, then is not 0, then you add it, store it, and then jump back to start again, where you read the next number and continue this process until a 0 is read in. Okay, so only this is the change between these two programs, and how to make this instruction is just exactly the same as jump in. Let me show you. So this is jump in. So you can see that exactly the same what we are trying to do. We are trying to put this value of done in PC. Okay. But in case the number, but this we have to do only if the number which has been read in is 0. Okay. Now, if it is not 0, then what do? We skip this. Okay. So we open the test condition and you look at the first condition. So we are checking if AC's value is not equal to 0. Okay. Then you omit this. Okay. That means if the value of AC will be 0, then this will be performed and we will jump to done. Is this clear? So this is question number 11 for you. So we've completed the entire practical list.